Today, we're going to look at the workflow. You might be uh, very familiar with our products. You might not know us at all. Um, but regardless of your experiences with us, sometimes it's nice to, take a little bit of a step back and look at just the workflow overall and look at the products and look how we get from the beginning to the end. And also just to discuss a little bit about where the company's going, the types of things we're looking at. And ultimately, as an organization, we are trying to make radar measurements more useful, more accessible to a wider audience so that anyone that's using this type of technology or anyone that receives information from this type of technology finds it useful. And in the end, whether you're receiving data for finding a pipe or measuring the thickness of a material, finding a void, whatever it might be, you should be able to try and do that with ease, rather than finding it tricky or being put off of using radar again in the future. So we're trying our level best to make this more accessible with more automation. So you're going to see that from us this year, and easier hardware, make that easier to deploy, um, and tools that are accessible to people that don't use GPR typically, that you might be sending this information to, and allow them to have a bit more of a dynamic report rather than something that's fixed. So we're moving in different ways, different branches, and looking at different people's needs depending on where they are in this process. Okay, so we tend to look at our workflow as capturing data, analyzing data, visualizing it, and then making a decision as part of a project. Okay, and there's parts of our products that sit in this workflow. So we use Examiner Collect, Examiner Specialist, Examiner Explore, and then that forms part of a plan where you might make some decisions. Now, for those that know us very, very well, you may have noticed that we have started to use the terms examiner for all of our product portfolio. And that's really so that people understand where they are during this process. So Examiner Collect is where you are using the hardware and you're in the vehicle and you're collecting data, okay? Examiner Specialist is Examiner, okay, where you are interacting with the processing of that data cube and refining and mapping and picking targets, things like this, okay. Examiner Explore is a new platform which is web-based, which is aimed more at engineers and asset owners that have less knowledge about radar per se, but are more interested in the measurements and applying it to their asset. Okay, so it's a little bit more accessible and it's web-based, so it's smaller in data size, so it's easier to transfer. Okay, I'm going to show you a little bit about each of these steps. For the webinar, we're all used to these by now. You're all muted, otherwise it would be chaos. But we have a Q&A function you're welcome to use. Just put whatever you want in there. Kent's also with us in the background. He will answer during the while I'm talking, so I can focus on this. But at the very end, we'll hopefully have a little bit of a discussion there as well. Okay, so there'll be a bit of time at the end. And all of the questions and answers are visible to everybody. This is me. I know some of you already, and if I don't know you, my name is Paul Collins. I work for Kontur, of course. I'm a technical sales engineer, previous user of the technology as well. So I have some field experience too. So I have a little bit of understanding of the types of difficulties customers have, and also developing the new solutions that we have coming out in the coming months. As a company, if you don't know us, we were founded in 2001. We have a radar system or solution that we manufacture. We manufacture in Norway. We are a non-destructive evaluation builder. So we believe that we can evaluate the subsurface without destroying it. We are pioneering in many ways. Namely, we have an array that is step frequency, and we were first to market in 2001 in this type of approach. And we have a presence globally. We have 3 hardware products. This is the Mark 6. For the US customers, it's pending FCC approval at the moment, but our Mark 4 system is available globally. Mark 6 is available everywhere else apart from the US, which we are waiting for approval on, which should be, fingers crossed, later this year. We have 3 parts to this. We have an air sensor, which is designed to be lifted away from the surface of the road, which enables us to collect data at higher speeds. This can be collected at posted road speeds. Okay, so obvious advantages there. Ground sensors, one of them is the number 2 there, which is a little bit higher in resolution since it's closer to the ground and gives you much more penetration in terms of depth. This is excellent for bridge decks and utility mapping. We have a 3rd sensor, which you can consider as a supercharged version of the ground sensor. It's larger, has bigger antenna elements that are separated, and it's focused on difficult or challenging environments where you need to get more depth penetration, or you need to focus on a little bit more, let's say, geological imaging. Okay. With our new sensors, we have some key features. Namely, everything is in one unit rather than separate. Okay, we have embedded IMU, which allows us to stabilize more the positioning when you have loss of GPS positioning. It also has an embedded or integrated RTK GPS, which means you don't have to have an external GPS connected to the unit, which is quite nice, to be honest, in terms of purchasing another GPS device to go with your hardware. We have an extended range. Our previous range was 3 gigahertz. This one now will scan between 30 megahertz and 4.5 gigahertz. So it's been extended. We have a minimum dwell time of 300 nanoseconds. This is a bit technical and not necessarily for this particular webinar. The channel spacing is 7.5 centimeters or 3 inches between each of these channels. So we have a multi-channel approach. Okay, it produces a footprint of data that creates a 3-dimensional cube of the subsurface when we are scanning. Okay, the deep antenna, as I mentioned earlier, is bigger. So the channel spacing is twice as large. Okay, so it's 16.5 centimeters or 5.5, so almost twice as far in terms of separation of channels. Okay, but it allows you to get much deeper. It also has a frequency bandwidth up to 1500 megahertz, so 1.5 gig. Okay, and the signal to noise ratio is focused upon for that type of deeper prospection. And then on the software side, we have the Examiner portfolio. So we have Examiner Collect, which allows us to capture the data in the field. This is installed on each of the sensors. So you don't have to download anything from anywhere else. You plug your laptop into it and you can download the application directly from the sensor itself. We have Examiner Specialist. This is designed to handle our data and our data only. It's designed to handle large GPR projects. It's nice and quick, fairly easy to process with. We have templates and things like this to allow for easier processing. It's updated twice a year. So we normally have one just at the beginning of the year in January, which is a major release, and we have a support release in the summer. Okay, and we have Examiner Explore, which is available now. If you're interested in this, I'm going to show you some videos on these software applications. If you're interested in Examiner Explore, contact us or contact your sales representative, and we're going to take you through that and give you access to Examiner Explore. Okay, this is a cloud-based application aimed at asset owners, which enables the data that's come from Examiner Specialist to be shared with you in a more simple platform. Okay. A reminder of applications, if you've never seen this before, these are the typical ones. People will push the envelope a little bit, but in general, these are the areas that people are working in. Probably the top three are roads and pavements, bridge decks, and utility mapping. So the first step is capturing data. We capture three-dimensional subsurface data, and we do it on a large scale typically. All right, you imagine these antennas, especially the air-launched one, can travel, let's say 65, 70 miles an hour in a lot of scenarios. With a 6-foot array, you're going to be collecting a lot of data per day. If you want to collect in ground, of course, it's going to be slower, but you have the opportunity depending on your environment and where you're working. If it's high speed, then air launched is your choice. Of course, it's going to be a little bit shallower in terms of depth prospection, but this isn't typically a pavement mapping device. All right, and then with ground coupled, a little bit slower, but very useful for bridge decks, utility mapping, void detection, these kinds of applications. We have step frequency, which means we don't have a central frequency. We scan everything from our spectrum. So from 150 in the US, this is, to 3 gigahertz or 4.5 gigahertz with the Mark 6, okay? Outside of the US, we are able to go lower than that, okay? So we're able to capture a lot of detail, a lot of targets, because we are not focused on one particular application. So if you want to extract a lot of information from a single survey, you can. So we find people that will initially begin out their journey with us as utility mapping professionals, and then they'll drive over a bridge and they'll realize that they can see the details of the bridge very, very nicely. And then they might move off into a tangent to start collecting bridge data as well. Okay, so there are multiple routes you can take with each sensor. Since we have everything in one unit these days, it's very quick to deploy. We have less need for external positioning systems since we have the embedded RTK GPS, and we have an IMU inside the box. You can collect data quickly because we have high driving speed, and we also reduce the power consumption, so you have longer survey duration. Typically, people power the units from the vehicle itself. We have high quality data. Since we have positioning from an IMU, which is very nice, and we have a flexible frequency range if you choose. For those that know us very well, you can have the extended band range, bandwidth if you want, up to 4.5, or you can reduce it back down to 3 if you prefer. Okay, you want to get what you're used to. Okay. So with Examiner Collect, the survey settings can be manipulated. So you can configure your survey settings depending on what you're looking for. So you can change the desired depth, okay, time window. You can change how often you take a measurement, okay. So it's very configurable. You can monitor what's happening as you're driving. Okay, so you can see the quality of your positioning, you will get the speed that you're driving, you will have audio and visual warnings. So you don't really have to be looking at this while you're driving around. You can also look at the power input, the amount of space you have on your disk, the temperature, all sorts of different things as you move. So you know really what's happening with the system and how the system's performing. You have navigation assist, which gives you the trajectory in the surveyed area that you've already collected. When you're doing multiple scans, you can see that you're overlapping or that you're coming up to the next part of your survey area, for instance. You have scan sequencing, so you can choose a different scan pattern, and you can tune that to the antenna to fire and receive on any sequence you choose. All right. As it says here, you can decide, particularly in railroad or railway scenarios, where you might want to avoid the railway tracks. Okay. And a little known but very useful tool inside Examiner Collect is the digital markers. So if you see something as you're collecting data and you want to place a marker in there, so to remind yourself when you're looking at the data in Examiner Specialist of where it is, you can press a key, create hotkeys of where these features are as you're driving along. Okay. Here's a short video on Examiner Collect. Here's the trajectory. You see the vehicle moving. You have an embedded video. This is the video of us driving into a tunnel. On the right-hand corner, you see the speed, maximum speed, traveling speed, incoming data. And at the bottom, you have a little bit of feedback of what's happening. Okay, so we have the IMU, which is initialized. We don't have any GPS. This is the IMU taking over since we're in a tunnel. Okay. But even so, we're in a tunnel, you see that trajectory is still taken care of, all right? As with all IMUs, the longer you are without any positioning, the more the accuracy starts to expand, okay? But we found in testing that it is very, very useful. This is an extreme case, being in a tunnel. So what we're going to find is a lot of people that are using this in typical scenarios where it's tree-lined, tall buildings, where you might be drive under a structure when you're doing a pavement survey, where you have those moments where there is no external GPS positioning lock. But those moments where it happens and the IMU kicks in, you're going to find that it's a very nice, smooth trajectory. When we move to the next step of the workflow, we start to analyze the data we've collected, okay? And this is done with Examiner Specialist. So it's purpose-built, allows you to work in 3 dimensions, and you can measure and extract the features that you are interested in. It's quick. We're always working on Examiner. It never stops. We are constantly working on it. In fact, we have some very nice additions coming in the summer. But it dramatically reduces the time that you require to get from raw to something to evaluate. Okay, it's fully georeferenced, so it's like a GIS suite. Okay, has real-time rendering. You can pan, zoom, deep dive, all in full resolution. We have multiple processing options. So the typical stuff you'd find in a GPL processing suite with filtering and background removal and migration. Okay, so it's always there, and we're always creating new ways of processing your data as well. It's as user-friendly as possible. We try to keep the software as clean and presentable as we can. We don't want to make it too congested and too cumbersome, difficult to understand. Okay, so we're trying to make it user-friendly. There are lots of guides and PDFs and videos that you can watch from Examiner to help you understand what's going on. And of course, we have training for every step that you might take. And we also have support that you can lean on when you have particular projects that you're considering taking or have already done and need a little assistance with. And we have easy import and export, and we use all of the typical industry standards that you might come across to bring in and export out. Okay, and we try to stay on top of all of those as they start to become popular. Right. Here's a little video of Examiner. with mapping that's been imported to put the GPR data in context, but you can also see a little bit of the samples of the resolution and detail of the three-dimensional data you can collect. All right. So a lot you can do with Examiner Specialist is a huge package of processing tools, and you're going to see a lot more automation in Examiner as well. So some of the common things that you use, for those that know, like interface tracing, is going to become more and more automated. When it comes to visualization, of course, you could stop in Examiner Specialist and you can generate all of your traditional reporting and visualization from there. Okay, you can do it from that. Or you can export information and start to collaborate with others using Examiner Explore, which is only just been released. And if you're interested in using this or trying this out, contact us, and we're gonna show you how to access it and use it. So once the data has been surveyed, you can visualize your targets, obviously in 3 dimensions, and extract the information you need into a report. But using Examiner Specialist and sharing this information is quite big, right? So you can reduce this and use a cloud-based visualization tool for collaboration. It's aimed at non-GPR experts, okay? We train people in Examiner Specialist and Examiner Collect and everything else, okay? But in Examiner Explore, it's designed to be small, megabytes of data in a simplified graphical user interface. That is more like a collaborative working tool. You have trackers inside the toolbox that are automated, so you can set it to look for certain elements like layer thicknesses, cracking, delamination, voids, okay? And they are being developed as we go. You can deep dive into certain areas. Even the platform will tell you where to look. All right. So if we have a very long road, and it's not uncommon these days to have a network level approach, we can focus on areas rather than worrying about the areas that are actually fine. Okay. These automated analyses, at the moment, they are focusing on, like I say, thickness, cracks, and delamination. Okay, but we are moving forward and forward and forward, and we will listen to recommendations from, of course, users as we always do, and the industry in general as to what is required to help maintain and build better quality assets. There's an export function as well, where you can export all of the cross-sectioning, all of the statisticals, all of the numbers that you want to do things in a traditional way, also from Examiner Explore as well. But really, the trade-off here is that in Examiner Specialist, it's okay for people that are trained in GPR analysis. And then you have another side of this, which is people that understand their asset in great detail. And there is also always this trade-off between the two. And sometimes the measurements are in the best hands of the asset owner because they know what they mean to them. Okay, they know that something is too thick, too thin, what is severe and what is not severe. By placing it in their hands, they do grab some extra value. Okay. Let me show you what it looks like. Okay. Okay. So the idea, of course, is you can extract this from Examiner Specialist. It's a couple of clicks, and then you can create a project and invite people to that project. A little bit like Microsoft would handle something. Okay, so you can silo people and you can bring in people from specific teams that you're working with and invite them to come and take a look at the project, but not bring them into an environment where there is a lot of radar data. Okay. And ultimately, we are trying to create something for people that they can make a decision on. So all of our products are designed for an insight into the subsurface that becomes more easy to share, and really useful to somebody that is not um, um, trained in GPR processing itself. And really, that's what we all do with GPR data. Anyway, we filter it down until it becomes something that the engineer can use to make a decision or to become part of their overall assessment in a project. Okay. In terms of the timeline, these are the products that sit in there. Okay, so when we capture, we have sensors, examine and collect. So we have ways of manipulating the data we're collecting, the density of that data, the depth, the quality of it. We can see where we're driving, what we're collecting. When we analyze, we have examiner specialist, which has its own reporting tools, its own statistical evaluation, its own visualizations. And then if we want to communicate that in a web-based platform, we can extract into Examiner Explore, where an engineer or combined, we can have a discussion on the findings. Okay, and then ultimately they will make decisions. Our systems are cost-effective, efficient. We have high-quality data collection. Since we're putting everything into one unit these days, we have less time on site. We reduce time analyzing data, and that's going to escalate as we bring in more automation. With simple visualizations of subsurface information, we have more tools to share and collaborate. We're providing valuable insights into the subsurface. And we generate maximum value from every single survey because we have step frequency and we can see more. Okay. And ultimately, we want people to be able to make decisions. So planning, knowing what the subsurface conditions are, reducing risks to their budget, reducing risk to field operators, which is something that's close to my heart, and then reducing change orders as the project is up and running. Any questions on the technology, the process, Examiner Explore, any part of the software packages? Let's see. Yes, it's yeah. Hi Adam. The Explore is has coordinates. It's the same type of GIS type platform as you'd expect. We will work on introducing more coordinate systems. At the moment, it's WGS84, but we will bring in more local systems as we go, as well as more automation and more processing types, so not just cracking and thicknesses and this kind of stuff. But one of the interesting things is the engineer themselves can create cross sections wherever they choose. So focus on an area that's out of spec. Let's say it's too thin. Let's say asphalt is too thin, for instance. And then they can cut that up into pieces. So they could say, well, I want 5 cross sections in this area, rather than coming to you as a consultant and saying, I want the wheel path. Well, what if the wheel path missed that area completely? So it gives them an opportunity to interact with what you've created in a kind of dynamic environment rather than a fixed report, which is quite nice, I think. This is the kind of direction we're trying to go. How would you approach an area where no reliable GNSS signal is available? How would the solution support that? Where there's no reliable GNSS signal at all? Well, lots of the times, you know, if there's nothing at all, if you, for instance, if you're inside and you had no GNSS available from the very, very beginning, we can use total station if you need to do that. Of course, it's slower, right? It's much slower. You can create base stations. That's no problem as well. We also have, which is not in this in these examples, we have support for really any positioning system, even if it's optical. So if you have a mobile mapping system, which is very common these days, you can take the mission from your mobile mapping system and add that as your trajectory in Examiner. All we really require is a timestamp. Okay, so we can take that too. and that is very common as well. But we decided to put the IMU into the unit as well as the embedded RTK device, really just to make it easier for the customer. So you don't have to bring in an external GPS. You don't have to purchase another one. And the IMU really is there for stability. Now, there are going to be extreme situations like I showed you today, which is, you go through a tunnel. But day to day, it's going to provide you with real stability just when you have those moments where you're driving and you drive underneath a tree, okay, or a structure, okay. It's going to really, really help. So it's going to increase your capability where you don't have to bring a total station out as often, for instance. Yeah. Is an additional license or anything else needed? No, it's not. Hey, David, we are in fact going to offer Examiner Explore for a period for free. We will amend your Examiner license to give you access to it. It's a tab or menu in Examiner where you can just create a data package for Examiner Explore and just upload it to the web platform. It's really easy to do. Create a user online, and then you can just upload the data packages directly from Examiner. It's very simple to do. Yeah. So if you're interested, give me a shout, and we will set it up for you, and you can start to try it out for yourself. Yeah. Okay. Thank you guys for joining me. This year's going to be very excited. Of course, we have new products, but we are also going to announce a few new things. You will see more from us this year, especially in kind of an exciting method for dielectric mapping, which is coming this year as well, which I think a lot of people will be interested in. We will be doing a lot of webinars surrounding these types of discussions. And as we announce new features for Mark 6, we will be showing more and more data from Mark 6 as well. So bear with us, because we want to collect data from people that are actually using it, not us using it, okay? Because we believe that it's best to take customers' real examples and show you those rather than us doing it, okay? We want to be authentic. Hey, Eduardo, what happens if during data acquisition, I realize I have a problem with a channel? You realize you have a problem with a channel. You will see it, but have you had an experience with us with a channel? Or is this another manufacturer, or? You can see, of course, the data coming in. Typically, if you have a fault with a system, you will see the data live coming in anyway, and you can tell that there's an
Hey,
issue.
Eduardo,
Yeah.
we just unmuted you so you can just talk.
Oh, sure. Eduardo, can you talk?
Hello.
There you go.
Hey.
Just to know if we make just only an interpolation during the acquisition, because what happens if I'm making a measurement and then I could realize that I have a problem with the channel? What is going on with the GPR? He makes an interpolation between channels, or how I can just realize that?
Well, I mean, we can interpolate between channels. We have a true three-dimensional cube, so we don't require interpolation actually. Normally, you won't have a completely dead channel. That's very, very rare that you have a channel that is completely gone. It doesn't really happen very often, if I'm honest. And so, of course, we can still rescue the rest of the data, so it's not really an issue. You don't get a warning in Examiner Collect. You won't get a warning their channel is faulty, but you will see an issue in the incoming data anyway, if there was one. Okay, but it's kind of rare, to be honest with you. Yeah, we also have a lot of flexibility with our system. I can't tell you too much about it, but we do have some fallback in our system, which is something I can tell you about, but probably won't tell you about publicly. But we do have some fallback options available to us because we were expecting, obviously things can happen, especially with units that are maybe in contact with the ground and you have a lot of vibration. Then things can occur. You hit it on something could happen. Okay, but we're quite stable a lot of the time. But we do have fallback options if something like that happens, which we handle in Examiner. So it's something we've done for 20 something years. So we know what faults can come up and we know how to handle them. And normally it's handled in Examiner, actually. Yeah.
Okay, thank you very much.
Yeah, no worries. And if you want to have a more in-depth conversation on how we handle that, then absolutely reach out to me and we can talk about it and I'll tell you the secret. Huh?
Okay, thank you.
All right. Yeah, absolutely. Okay, any more questions? If not, Kent, we have a roundtable coming up this month or next month?
Yeah, we're probably going to end up doing that on either the 23rd or the 30th of May.
Okay.
It's pretty interesting, just to give everyone a heads up. We had a couple of folks like Mike Heitzman and Bill Owen from Caltrans give us a list of their top thoughts about what pavement and road problems may be mitigated or understood better through non-destructive testing.
Okay.
So we've sent out a survey to a ton of different DOTs who are the pavement specialists for those agencies, and having them vote on the top 3 of those pavement problems. And we are going to have a panel of agency and practitioners, private company practitioners, to be able to discuss these top 3 problems and figure out some solutions, hopefully some very interesting ones, to get around some of the issues that are existing right now in the industry. So that'll look for that towards the end of next month, and love to see everyone there.
Great, perfect. Follow us, get in touch with us, interact with us. We want to talk to you. If there's things that you want to try and overcome, ideas you have, something you want to do, let us know. There are the contact details. We appreciate you attending these webinars. We really do, and we will be in touch. Keep an eye out for what we're up to, and if you, yeah.
One more thing. I'm sorry, Paul. We're also, to our existing customers, we're going to be sending out probably early next week our first ever customer satisfaction survey, which is a very in-depth questionnaire. Should only take maybe 10 minutes to fill out, but we would like, and we're going to take very seriously your responses. So please do look for that. Feel free to leave that around in your company to anyone who, if we send it to you and you think someone else is more appropriate to answer, please do. But it's going to be kind of from soup to nuts to make sure that we are supporting our customers as best we can. So please look for that next week.
Yeah, absolutely. That's incredibly vital for us. So yeah, that's great. Thank you so much. And we will see you again soon. And thank you once again for joining.